is titled the unit circle. Okay, so we'll talk about what that is. We also get into this idea of we've touched on this a little bit just in regards to your calculator, but what are radians versus degrees, and that's where this is the topic where we get into like what radians are. Okay, so you hear radians, you think of radius of a circle, and that's what it has to do with. So before we kind of see what that means visually, we're going to practice some conversions from degrees to radians and vice versa. So they just give us a conversion factor to go each way. So if we want to go like in the first one, we want to go from degrees to radians, degrees to radians. This is our conversion factor right there. So we just multiply by that. We just take 60 multiplied by pi over 180. So we got 60 times pi over 180. Which just gives you 60 pi over 180. And then you would just reduce 60 over 180 to get 1/3. So that would equal pi over 3 radians. Or, you don't really measure radians like, well, if you punched in pi divided by 3, it'd be about 1.05. But usually you keep them in fraction form since pi is irrational. All right, and then to go the other way, basically you just do the reciprocal of that fraction. All right, so if we want to go back to degrees, from radians to degrees, our conversion factor is that fraction flipped, okay? The inverse of that. All right, so if we take 5 pi over 4 radians times 180 over pi, the pi's just cancel each other out. If you wanted to do some cross canceling ahead of time, that might be helpful too. So really, this is going to be equal to whatever 5 times 45 is over 1, which is going to be 225. Okay, and once we get more into this, the big idea, you'll kind of generalize that anything that's over 1 pi is going to be over 180 degrees. So an answer like that would make sense numerically, but we haven't really gotten that far yet. So why don't you guys take a couple minutes and maybe try to do like just pick 2 of each, maybe. Okay. Well, I'll give you like 3 minutes. If you can do all 8, that'd be fine. But I would start with pick 2 of each, 2 from 1 to 4, and then 2 from 5 to 8. And then if you have extra time, maybe try to finish them up, and we'll kind of review the answers. That way you can just make sure that you have it. You're able to convert each way. And if anybody's having any trouble, you can grab me while the timer's going. And just so you know, too, if you were here yesterday, you probably didn't try to like watch the video like I record the lesson, but if you did try to watch it, I put it as an ed puzzle because I made a mistake when I was going through the notes for 3rd period. So that's why I made it an ed puzzle video. I was just going to say that. Because you can't edit it if it's just a YouTube video. You can if it's an Ed Puzzle video. All right, a couple more seconds, and then I'll call on you guys. Just make sure you have it. And since I told you to pick any two, I'll let you pick which one you converted. All right, so Carly, start us off with any one from 1 to 4. All right, 5 pi over 6 radians is correct. Very good. Remember what I said about, 1 pi being equal to 180? Like, so think about 5, 6 is pretty close to 1, right? 150 is pretty close to 180. So, just start to kind of see that, and we'll have a more visual representation of what I'm talking about when we actually look at the unit circle. Parker, give me one more from that set, 1 to 4. 3, 7, 5. You gotta shine away from those negatives. Yeah, so with the negatives, they just, it's the same thing. It's just going to be negative in negative radians. Okay. Anybody want to check any of the other two? Yes. Yeah. Yeah, you're going to want to leave it as a fraction just because stuff like sixth, they're like a lot of them are in sixth. Some of them will be in fourths, and you could really use a decimal there. But with sixth, you get those nasty, decimals. So a fraction would be preferred there. Yeah. Does that make sense? All right. So moving down to the 5 to 8 set, Molly, give me any one from 5 to 8 in degree. Number 5 would be 240. Good. And we'll do one more from that set. Trinity, any one from 6 to 8. There's a negative. There we go. Negative 270. Anybody want to see any of those worked out or any of the others we didn't go over? Yeah. Yeah. All right. So just make sure that you choose the right conversion factor. So if we're starting, I don't know what I did there. You might see where my scroll bar went there. There it is. All right. So if we're starting from radians going to degrees, we want to use this conversion factor right here, 180 over pi. So if we just pick, say, number 7, take pi over 6 times 180 over pi. And then, you think about what cancels out. And then, 6 goes into 180. So then we just multiply, across, end up with 30 over 1. So that'd be equal to 30 degrees. Does that make sense? Anybody need to see anything else before we move on? All right. So now you have a little bit of an idea about what, radians are. Probably not really, but kind of. All right. Now on page 2, they give you a kind of a nice method for basically finding the sine, cosine, or tangent of any of these kind of special right triangles. There are some homework problems that I give you where this is not so helpful. So that's where we'll get a little more in depth. Plus, I think this is kind of a process. This is an example of a process that you might be able to remember, like for a test, but then probably, not much after that. Like it's just kind of a process that, it's fine and it works, but I don't think it helps you, conceptualize what we're actually doing. Okay, so we'll follow the process once, and then I'm going to give you try to give you more of a conceptual understanding of what we're doing here. Okay, so let's do this first example. Just kind of follow their steps. Okay. All right. So what we want to do is find the 3 trig functions, not their inverses, just the 3 trig functions, sine, cosine, and tangent for 150 degrees. Okay. Now we could just type those into our calculator, right? We could just type that in, and the calculator would give us the answer. But that's not necessarily the point of what we're doing. Okay, so the first thing we want to do is kind of get the reference angle. So your reference angle, to be able to do any of this, it either needs to be 30, 60, or 45. Without that, you're going to go to your calculator, okay? Because 30, 60, 90 are special right triangles, and 45, 45, 90 are special right triangles. So anyways, if we have a 150-degree angle, we talked about this yesterday, but our reference angle would be 30 degrees. They diagram that for us. So then that means that the trig functions for 150 should correlate with those of 150. The only thing that might be different, or the only thing that will be different, are the signs of one or more of those functions. Okay, or those ratios, I should say. All right, so they've already done step 1, step 2 for us. So then, how do we find the sine, cosine, and tangent of our reference angle? So that goes back to, that's a table on the 10-1 notes. So here's where it kind of gets a little, it's kind of you're like looking at the table and you're going back and forth and this, that, and the other thing. So if you don't have your 10-1 notes, this is the table I'm referring to. Okay, so if we look for sine of 130, it's right there listed. It's 1/2. Your calculator would tell you the same thing. Okay. All right, so sine of 130 is equal to 1/2, according to our table. And I'm not going to keep flipping back and forth just for just to go a little quicker. Cosine from that table of 30 is square root of 3 over 2. And tangent of 30 is square root of 3 over 3. Sorry, thank you. I put 130. Yeah, I don't know why I did that. Should be just 30. Thank you all. So yeah, sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. And tangent of 30 is square root of 3 over 3. And again, I'm not memorizing that. That comes straight from that table, right? And the last thing is, like I said, so those would be exactly the same. The absolute value of those would be exactly the same for 150 degrees. But then we have to consider the quadrant and adjust the signs, as they say. Okay. So how's this thing work? This basically, well, it tells you. This diagram shows the quadrants in which each function is positive. All right. So if it's in the first quadrant, they're all positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And fourth quadrant, cosine is positive. All right. I've heard teachers help kids remember this. If we were going to go back to this, as they say, all students take calculus, and that I guess helps you to remember that it's kind of a little acronym. Anyways, since we're in the second quadrant, this is where we are for 150 degrees. Then our sine is going to be positive. All right. So then the sine of 150, after all that, is going to be positive 1/2. The cosine of 150 is going to be, cosine is positive in the fourth quadrant. It's not positive in the second quadrant. So the cosine of 150 is going to be negative this. Okay, so negative square root of 3 over 2. I think you guys are starting to see what I mean by this is kind of a process, right? And then the tangent of 150, tangent is not positive in the second quadrant, so it's going to be negative this. Okay, so that's how this book this geometry book teaches you to do this. And again, keep in mind that your calculator could give you these values as well, except you wouldn't have they would be decimals. Instead of the square root of 3 over 3, you would have the kind of equivalent decimal. Yes?
It's like the 30 degrees of the degree isn't on paper that we have.
You wouldn't be able to do it. Right. It's either going to be, your reference angle for this process to be able to work, your reference angle either has to be 30 or 60 or 45 or 90 or, okay. So yeah, this only works for these special right triangles, okay? All right, so if all you were doing was finding, these trig functions, this process would work fine. But you'll have some, I'm trying to think of the wording on the homework that say, I think it says like what angle gives you, what angle is going to give you a cosine of negative square root of 3 over 2. So this process doesn't really work for that. And plus, this whole set of notes is called the unit circle, and we haven't even really looked at how a unit circle works, okay? So to answer the last couple, let's see where we're at time-wise. Yeah, let's actually look at a unit circle, okay? So it's going to look real busy when I show it to you, but I'm going to try to explain how to... this is not on your notes, okay? So I'll show you what I would like you to try to sketch, okay? And then we'll look at how to try to use this beast. You have kind of a blank backside, so I would maybe try to sketch. We'll just try to focus on the first quadrant because everything else kind of comes from that. All right. So first of all, like what is a unit circle, right? So this is a circle that if we had a coordinate grid, a circle that basically has radius 1, right? So it goes through the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1, right? So it's a circle, literally, that has a radius of 1, all right? So based on that, you can develop a lot of these, these trig functions. So now we're going to talk about how to use it and how you could kind of draw this on your own, because it doesn't look very drawable right now, like, because I already have everything ahead of time. So again, basically what I want you to try to sketch is just this first quadrant, right? So try to just make a first quadrant and make your first points, 1 at 1, 0, 1 at 0, 1. And then the first thing you have to remember is kind of what we've talked about so far. What angles make these special right triangles, all right? So you want to try to just do your best. Obviously, you're not going to be perfect. But up from 1, 0, you want to try to go up like a 30-degree-ish angle, okay? Up from there, you want to try to go 45. That's a little bit easier, right? 45 just splits these two. And then up from here, or you could say down from here, go 30. Okay. So you want a 30-degree angle, a 45-degree angle, and a 60-degree angle, ish, right? Obviously, we're not being perfect. Okay. So what these, you can see that what I've given you also to correspond with these are these ordered pairs, okay? Now, how in the world could you remember those ordered pairs? All right, let's kind of generalize, okay? So you notice what do all, if I'm looking at these 3 ordered pairs, what do all 6 of those numbers have in common? They're all over what? They're all over 2, right? So you start out with, they're all over 2, right? So if you were trying to come up with these points, if we were taking a test and it was an open note and you had to sketch this, you draw your first quadrant like I just said, and then you try to come up with these points, and then you go over 2, over 2, over 2, comma, over 2. Right, so that's where you would start. Now, the numerators. Does anybody see any kind of pattern, say, from here to here with the numerators? Kind of. What's kind of the pattern? It goes 1, 2, 3, right? Not exactly 1, 2, 3, but we see those numbers, 1, 2, 3. What about going the other way, from here to here? It just reverses that, right? So you go 1, 2, 3 down the other way. So 1, 2, 3, 1, 2, 3, and then you just take the square root of all of them, all right? So the square root of 1 is just 1. That's why you don't see the square root symbol. Square root of 2 is the square root of 2. Square root of 3 is the square root of 3, right? So every numerator has the square root over it. And again, I know this is kind of a lot. I told you it would be. But so once you have it, I'll give you a second to get it sketched. I wouldn't worry as much about these radians. I marked them off as radians too, but I would worry about just the ordered pairs for right now. So, like from the first quadrant, like everything else would build off of that, right? So if I had like if I had something in, say, the fourth quadrant, right? If I wanted to plot this point, then I would just go as a reflection from this point here. Okay, so notice they have the exact same x coordinate, and then the opposite of the y coordinate. Okay, so that's why the first coordinate is so important, or the first quadrant. Sorry, I said coordinate. All right, now that you're looking at this beast, it's like, how is this thing helpful? Okay, so let's try to use this to do the next example. Instead of following their process, let's try to look and see how we might use this thing. Okay, And once you have it sketched out, then you can continue to reference it. And we'll practice it tomorrow. We'll practice using it tomorrow when you're actually doing some practice problems on your own. All right, so let's try to figure out the trig functions for this. Without following their process. You could follow their process, but let's try to do it without. Let's try to do it using the unit circle. All right. So first of all, if you didn't have, you know, I have mine marked off in radians, but if you didn't, the first good step would be still to convert to degrees. Okay. I think our brains can compute that a little bit better, anyways. So if we converted that to degrees, we're taking 11 pi over 6 times 180 over pi. And I can tell you right now, 11 pi over 6 is really close to, 11 over 6 is really close to 2. So this should be really close to a 360-degree turn. Okay, if 1 pi is equal to 180, 2 pi is equal to 360. Okay. But anyways, we could just work it out. All right. So when we do, we get that would be equivalent to 330 degrees. 330 degrees. All right. So a 330-degree angle would be, remember, we rotate, we rotate this way, right? But how far? It would be 30 degrees short of a full rotation. Okay, so we're gonna kind of try to stop like right there, right? Okay, so now that we kind of see that, here is how you can take these points and know your ratios. Okay, know your trig ratios. All right, so you're based on your coordinates. Here's how it works. All right, so the sine is equal to your y coordinate. Your cosine is equal to your x coordinate, and your tangent is equal to y over x. Okay. All right. So that means, based on this diagram, that our sine should be equal to negative 1/2. Our cosine, the x coordinate, should be square root of 3 over 2. And then tangent might be a little bit tricky, but here's how we do that. If we do y over x, then we're thinking, then basically you're thinking negative 1/2 divided by the square root of 3 over 2. So you'd go like this. You'd go negative 1/2, times the reciprocal. So that ends up giving you, if we cancel those out, negative 1 over the square root of 3. Bless you. Which is correct, but then you would have to rationalize that denominator, okay? So you see that it's never really easy, no matter what we do. But anybody remember how to do that? Anybody remember how to rationalize that denominator? What would we need to multiply? Go ahead, take a shot. That's all right. Nadeepa? Yeah, square root of 3 over square root of 3, right? Because the square root of 3, remember, squared is equal to 3, okay? So without showing all that, what we would end up with is negative square root of 3 over 3. Okay, so that's my tangent. Now, if you want to double check me on that, you could try that same process we did earlier. Okay. Also, you can type them into your calculator, right? So you could like to double check, your cosine, for instance, you could do cosine of 330 and then type in square root of 3 divided by 2. See if you get the same decimal. All right. Let's see. Is there one more? All right. So I'm going to have you guys try to partner up with somebody and or work on your own if you want, and try to just finish up and get try to do that last one. Okay. So just try to find sine, cosine, tangent of 315. All right, so that one's in degrees, not radians. So yeah, just try your best. Feel free to work with somebody, and then we'll kind of touch base at the end and see if you guys got anywhere on it. It may be the case that you don't, okay, but I've given you a lot of information, but give it a shot. And I'm going to go ahead and I guess I'll leave the tape rolling just so we can review the answers to end out the video. Told you guys this was going to be a fun lesson. So just kind of also in the back of your mind, there's one example that we didn't, that we're not going to get to today, and it's really easy to go through. So I'll probably do that at the beginning tomorrow. There's not a whole lot to it. Can you go through the chart? Yep. All right, guys. Obviously, you're not done, but I just kind of need to get this video wrapped up. So I'm going to go ahead and put the answer key up there. I recommend you just keep trying to do it till the bell. Could you produce these on your own? In other words, but here's the answers, and then we'll finish out the video that way. So your sine of 315 is equal to negative square root of 2 over 2. So if you got that, nice job. Cosine of 315 is equal to square root of 2 over 2. Positive square root of 2 over 2. And then tangent 315 is equal to negative 1. Negative 1. All right, so I'm going to go ahead and end the video, and then I'll take questions with whatever time we have left.